Here we have the quotient rule, which is different than the power of a quotient that we just talked about. So it is going to be very important to keep these all straight. Just drill yourself on the rules. It's so crucial. This one says if we have m and n that are positive integers and a is a real number, then a to the m over a to the n equals a to the m minus n power. Basically, and this is really nice to do out to where you can see what's happening here. Let's say that we had x to the fifth over x squared. We are basically dividing like bases. That's what this rule is saying. Well, according to the rule, we would subtract the exponents, m minus n. But let's see why. If we were to subtract the exponents, 5 minus 2 would give us x to the third power. So we know what the answer should be, but let's see why. X to the fifth is really x times x times x times x times x. 5 of those. And x squared is really x times x. Well, remember, if you've got common factors in the numerator and the denominator, you can cancel those out. So we've got a common x on top and bottom. Here's another common x on top and bottom. So once we've canceled those out, or reduced them to 1, technically is what's going on there, then all we're left with is x multiplied to itself 3 times on top, which is x cubed. So this is what's really happening behind the rule. Now let's apply this. The first time, let's use it by absolutely applying the rule, and then we'll look at sort of a shortcut. Okay, so here we have some x's. We are dividing like bases, so we would subtract the exponents. So that would be x to the 8 minus 1 power. And again, we have y's, where we are subtracting the exponent because we're dividing like bases. So that would be y to the 6 minus 5. And then when we clean this up a bit, x to the 8 minus 1 is the same thing as saying x to the 7th. And y to the 6 minus 5, well, 6 minus 5 is 1. So that would be y to the first power. But we don't have to write it if it's a 1. We assume that it's a 1. So there would be our answer. Now once you have these ideas kind of down pat, then you can start sort of taking some shortcuts, which is nice. Like looking at this problem here. If we only had 7 over 14, we could deal with that. We would say, well, 7 goes into 7 one time, goes into 14 two times. But then we've got x's to deal with also. Now you can either do it by the rule, or don't we know that anything over itself is 1? Or another way of looking at it is you can cancel common factors on top and bottom. So those cancel each other out. They're the same thing. X squared over x squared is really just 1. Now here for our last item here, we have y to the 6th and y cubed. A rule says we have to subtract the exponents. Now kind of visualize in your mind also writing out y 6 times on top and 3 times on bottom. When you start canceling those, you're going to be left with some y's on top, right? There's going to be more on top than there was on bottom to cancel. So when we do the subtraction, 6 minus 3, that will give us y to the third power. So we could kind of picture that canceling also. Now all we have left on top here is 1 times y cubed, which is y cubed. And on bottom, the only thing we have left is a 2. So our answer would be y cubed over 2.